ESP32 based designs such as this thinking ashtray can bring a lot of joy to your life, but only if you don't make common mistakes. And I recently had to review a design for a PLC controller from a client, and the client allowed me to post the mistakes. And because they are just very common, here is a quick TAM bashing the circuit. So, there's the old saying that if the magnetics don't get done, nothing else gets done. But our friend here makes it even easier for us, because let us start out with his power supply. We have here an ESP32 design, and here we already have the first problem. This is a 1N4148 diode, or as I like to call it, the chicken diode, because every cadet gets to learn about it. But now if we look at the data sheet, which I'm showing you here, we see that the maximum current is just 100 milliampere. And now we see the ESP32's power consumption, so this already is the first problem. And the second thing which I don't like here is why the diode is here. The idea behind the diode most probably is to prevent backfeeding into the USB port, but it doesn't do that. The diode would need to be here if this would have been the idea. And yes, also here, we see here it says a 24 volt AC/DC, and we are using a linear regulator. I mean, yes, I know that linear regulators, they do have their benefits from a ease of use situation. But if you now look here at the other diagram, you understand why it's a really bad idea, and I would have put a switch mode regulator here to make things easier. And yes, I found ourselves something small special as well. Here we have a 25 volt electrolytic capacitor at a 24 volt AC input voltage. I mean, there is a Gratz bridge here, so you need to think what is the maximum voltage which you see here. And also, in general, an electrolytic capacitor is not a tantalum capacitor. So you should have some headroom. I would go for a 35 or a 40 volt electrolytic capacitor here, just in case, to play it safe. And then here we have two more things. First of all, the schematic is stupid. Here is the input, here is the output. Turn it around, you lazy bum. And secondarily, here on the output side, probably this was an act of idiocy because the schematic was turned around. We find a protection diode. Why in the name do you put a protection diode on the output side of a linear regulator? This is like complete insanity for a schematic like this especially. But I think this was a mistake because it turned around the input and the output sides. So, and we are still playing around with the power. Incidentally, yes, here one could use a field effect transistor also, but that is a topic for a rainy day, and it's not raining much today, so we are going to move over here. Here we have an ESP32, and where there is an ESP32, there is trouble, because the ESP32 is known for its extremely bursty power consumption. And I don't see any MLCC protection capacitors around here anywhere stabilizing the voltage. And so it's only a question of time until when this beautiful design will have a date with Mr. Brownout. And so this is another very important mistake. So now we got the magnetics done, but of course there's even more hiding in this absolutely charming design. And this is a really bad thing, which I personally blame the Arduino and the Raspberry Pi module makers, because they put a pull-up resistor here, a pull-up resistor there, and maybe also a pull-up resistor in the sky. But as you see here right now, the I2C is an open drain network. And if there are no pull-up resistors anywhere, the bus cannot levitate up. And if it cannot levitate up, it doesn't work. And here, of course, he forgot the pull-ups. And this is a really nasty thing, because usually he only tested his design with external modules. And these modules bring the pull-up resistor. So this is a problem he only finds in the very last step, and then it becomes a very expensive rework. That's a lot of fun. Don't do it. And here finally we have one more charming case of having sex with modules. We see here an RTC module connector, a 3.3 volt I2C bus, and what is he supplying? 5 volts. Okay, maybe the module requires this, but in general, I don't like the whole idea of this so much. And with this, we've basically been looking at the first few things, and now we also take a quick look at his PCB. And here we come to the PCB. First of all, the original sin, you print one layer per page, because your reviewer doesn't have radar eyes, and it is very difficult to keep a part black on black. So, of course, this in a way limits what we can do on the PCB, but there are still a few nice topics. First of all, you know, printed circuit boards are technical components and not a swinger club. The components and the traces don't need to be very close to one another so that they can have sex with one another. They don't want to have sex with one another. And you see here, these two are very close, unneededly so, which makes crosstalk much easier. And the second thing which I don't like is here he's got his linear regulator, which is already cooking itself, and he puts it nice and close to the electrolytic capacitor. The electrolytic capacitor really likes the heat. The hotter it gets, the shorter it lives. So yay, bring in the heat, yay. And then another thing, which I also sometimes do, admittedly, because I'm lazy, here we have the antenna area on the ESP32. This is routing verbot. Below this, there should be nothing, and especially no sensitive signals and no ground plane. I mean, it doesn't kill the design, but it does significantly increase power consumption, cause more EMI problems. It's just not a good thing to do. And then finally, there is so much space here. Why is there no mounting hole? The PCB doesn't like to fly in the sky, and if you install yourself a mounting hole, your life becomes just so much easier. And now, to bring this to a close, I hope that the things which I've shown here are somewhat helpful to you, and I hope that all of your designs will work much better in the future.